Hello and welcome back to the nutrient description series. Today we're going to talk about fat-soluble vitamins. One of my favorite groups of nutrients there are out there because they are so underrated and so important for us. So let's begin. Fat-soluble vitamins. Okay, so since we are talking about vitamins, we have to know the concept of vitamins. Vitamins are molecules, different molecules that have the same vitamin functionality. As being fat-soluble, these vitamins are absorbed as fat. Indeed, they are digested as fat, they are present in fats, and then they have to get emulsified with the bile and converted into micelle to get through the water layer and then inside the enterocytes. Once inside the enterocytes, they enter the chylomicrons and they go through the lymphatic system and then to the bloodstream and then to the liver. The elimination of these vitamins is very slow and is through bile in feces. So as they are present in the liver, they are sent into the bile and then the bile is secreted to the duodenum, and once inside the gastrointestinal lumen, they will follow, not get absorbed again, and they will get out in the feces. We have to mention that vitamin A and vitamin D can have a toxic accumulation because these vitamins can accumulate. The deficiency is very rare since we have accumulation, and they do have various important functions in the body. So we're going to see each one right now. Starting with vitamin A or retinol. Characteristics. There are natural and synthetic vitamins. The retinol and the carotenoids are the natural. The retinol is present in the animals and the carotenoids in the vegetables. And then we have the retinaldehyde and the retinoic acid that are pharmaceuticals drugs. The retinol, the absorption rate is 90%, whereas the beta-carotene is from 5 to 50%. So retinol is always the best source of vitamin A. This is the concept of vitamins. All these four molecules, they share the same vitamin functionality. And the transportation in the bloodstream, as they are fat soluble, they cannot travel alone, so they have the retinol binding protein as for retinol. Physiological functions. So they are, the vitamin A is important for vision process, because we have the trans-retinol that is converted into cis-retinol, and then the cis-retinol is converted into cis-retinal, and that stimulates the conversion into rhodopsin and rhodopsin to opsin. And these two are very important for us to actually view and create an image in our brain. And then the rhodopsin is converted into transretinal, and the transretinal to transretinal, and the cycle repeats. But we need the transretinal from the diet. The vitamin A is also involved in the protein metabolism of mucous membranes and skin protection. So if we lack vitamin A, our skin will be more fragile, as well as the membranes of our tissues will be less protected. Our bones and joints are also very important because vitamin A is involved in the formation also of joints and bones and teeth as well, and it's also involved in growth and fertility. That is why it's very important in the early ages. The deficiency. Well, the RDA of this vitamin is from 700 to 900 micrograms, and the primary deficiency is due to a retinol deficiency in the diet. There is also a secondary deficiency, and that is due to a low protein diet and fat absorption problems, and also the lack of zinc can contribute to that. And as the main function of vitamin D is vision, the deficiency can cause night blindness. Then toxicity, well, normally is very rare, and It causes vision problems, bone pain, and liver damage. So, where we can find vitamin A in food? Well, in animals, we find the retinol, which is the most bioavailable form of the vitamin A, and we get it from liver. Liver is so high in vitamin A. Then the fatty meats, the oily fishes, the milk fat, and the egg yolk is also rich in vitamin A. In the vegetables, we have the beta carotene, and we can find it in orange fruits and vegetables, as well as in red and green. We don't have to fool us thinking that green vegetables don't have beta carotene because they are not orange. It's simply because the chlorophyll is a more dominant pigment in those leaves. Moving on, we have the vitamin D, the cholecalciferol. Cholecalciferol vitamin D characteristics is a vitamin we don't necessarily need to eat because we can synthesize it using UVs from sun, and it is synthesized in good amounts if we get enough sun. The metabolism is pretty easy. From the 7-dehydrocholesterol we get the cholecalciferol, and here we have to, the UV light converts the 7-dehydrocholesterol into cholecalciferol, and then the cholecalciferol travels to the liver, and in the liver is converted into 25-hydroxycholecalciferol, and then in the kidneys we add another hydroxy group, and we form the 125-dehydroxycholecalciferol, and this is the active form of the vitamin D. Physiological functions, calcemia and phosphatemia. This is the main one. The PTH, the parathyroid hormone, is also involved in raising calcium levels in the blood because vitamin D stimulates the reabsorption of calcium, and this is very important for maintaining bones and teeth, general health, and also for growing as well. That's why children should have this high too. Other physiological functions are immune and insulin response. Immune response, so no vitamin D, you will probably get autoimmune diseases, and lower insulin resistance. If you get vitamin D, you will have a lower insulin resistance. Insulin resistance is the pre-diabetes step. So if you have good amounts of vitamin D, you will increase your insulin sensitivity and maybe avoiding diabetes. Then the gene transcription and reproduction, because with vitamin D we have better embryos and sperm quality. The deficiency, the RDA says that we need to consume from 50 to 100 micrograms a day, and the deficiency in children causes rickets. That's why it's very, very important that children get the vitamin D they need. And in adults, the deficiency creates osteomalacia and osteoporosis, and actually low sexual steroids. Toxicity of vitamin D will cause an hypercalcemia, and that can lead to headaches and tissue calcification, such as kidney stones. So we have to be careful, and the best way is to not exaggerate with the supplementation, because that's the only way we can get the toxicity. It's very difficult we get toxicity from ingestion or synthesis through the sun, so the only problem will be with the supplementation. Food sources, animal only, because the vitamin D3, which is cholecalciferol, is the only bioactive form we can get. There is also the vitamin D2 in plants, but we cannot really use that for activating the vitamin D. We cannot use that. So animal sources are liver, as in vitamin A, fatty meats, oily fishes, milk fat, and egg yolk. Moving on, we have the vitamin E, or tocopherols. Characteristics: is an hydroxychromane ring. It has 8 vitamins, which are tocopherol and tocotrienol. We have the alpha tocopherol and alpha tocopherol, the beta tocopherol and the beta tocotrienol, the gamma tocopherol and the gamma tocotrienol, and the delta tocopherol and delta tocotrienol. Tocopherol gets converted into alpha tocopherol. Then, as being fat soluble, it needs to get inside the micelles. It travels through the enterocyte via simple diffusion. Then inside it enters the chylomicrons and gets into the blood. This is passing through the lymphatic system. Once in the blood, it goes to the tissues and the liver. And then it can also enter the enterohepatic cycle for elimination through bile. Physiological functions: it's an anti-free radical, an antioxidant. These molecules here, the H2O2, the O2, the HO2 and the OH, they can create mutations, cancer, cardiovascular diseases. And what the vitamin E does is an auto-oxidation to reduce those molecules and prevent the creation of mutations, cancer and cardiovascular diseases. And once the vitamin E is oxidated, we have the vitamin C and the coenzyme Q10 as a backup to reduce the vitamin E so it can again make his function properly and reduce those forms. They also have anti-sterilizing and they prevent degenerative diseases, so they're very important. The deficiency, well, the RDA says 8 to 10 milligrams a day, and the deficiency can cause more probability in contracting degenerative diseases because of the free radicals. The toxicity is very low, and the food sources are vegetable mainly, seed and olive oils, legumes, nuts, and whole grains. And in animals, there are in less quantities in oily fishes and butter. And then, as last soluble vitamin, we have the vitamin K or phytomenadione. Characteristics: we have 4 of them, and 2 of them are pharmaceutical drugs. The phytomenadione K1, menaquinone K2. This is from the food and this is from the microbiota synthesis. And these 2, the menadione K3 and menadiol K4, they are pharmaceutical drugs. So K1, K3 and K4 are absorbed in the duodenum jejunum, and in the ileum colon the K2, because in the colon we have the microbiota that synthesizes the K2, the menaquinone. And then they enter the enterocyte and the chylomicrons, and then the lymphatic system. They go to the blood, and then from the blood they go to the liver, and they can have the enterohepatic cycle for the elimination through the bile and the urine. So this is, as always, as in other fat soluble vitamins and fats. Physiological functions: we have the blood coagulation. This is the most important because together with platelets and calcium, they activate the coagulation of the blood. So here is what happens. Platelets with calcium, they activate the thrombokinase that activate the prothrombin. And then with vitamin K, the prothrombin stimulates the thrombin. And the thrombin gets the fibrinogen converted to soluble fibrin and then to insoluble fibrin. And the insoluble fibrin will actually coagulate the blood. Then the vitamin K is also involved in the coenzyme Q10 synthesis. And this is involved, the coenzyme Q10, in the mitochondrial metabolism. And if you want to know more about the coenzyme Q10, I have a video talking about the electron transport chain in my channel. It's on the playlist of the metabolism. Vitamin K is also responsible for carboxylation of glucose residues and the bone metabolism, together with the vitamin D. The deficiency: well, the RDA says 90 to 120 micrograms, and the deficiency is not as common because we have the microbiota production. Toxicity: only in children supplementation of menadione K3, so only with pharmaceutical drugs. And food sources: vegetables, from leafy greens, seed and olive oils, tea or coffee, and in the seaweed. In animals, in the liver, there is a big amount, egg yolk and milk fat, especially fermented. Okay, so this is it for this video. These were the fat-soluble vitamins and a little mnemonic to remember them all. KEDA. KEDA. Anyway, I hope you liked the video. Let me know in the comments any suggestion or doubt you have. Subscribe to the channel if you're new, and I see you on the next one.